Alright, so now I'm basically going to be going over what a basic bellypan structure would look like. So this is what a complete bellypan structure would look like, and since we haven't learned what some of these parts are and do, this is what it's going to look like for us now. So now let's take away all the wires and go step by step. So when you're making your bellypan, first you want to make sure that your breaker system works. So if you look on the bottom, the battery, and to the right, the breaker. For the battery, the negative terminal, or the ground terminal, is connected from the PDP directly to the battery, whereas the power goes through the breaker, which is 120 amps, and this ensures safety when the robot goes wrong. Next, you want to power your VRM, your PCM, and other small cameras that are connected to the RoboRio. You connect your VRM either through the 30 amp breaker on the side of the PDP or the 20 or 10 amp breakers at the top. And in this picture, the VRM is connected to the side of the PDP, whereas the PCM is connected to the top breakers. Right. Now you want to add components to both the PCM and the VRM. And for the PCM, since we haven't learned about pneumatics, we won't be connecting any parts right now. But for the VRM, for example, you can power other things such as small sensors, or in this case, it's powering the radio and a network switch. Right. So now for a robot, you want the robot to move, and you need motors. But before you plug in the motors, you need to plug in the motor controllers, the talons. So the talons all connect to the sides of the PDP. And the important part is some motors require more power than others, which means that it needs more current drawn to it. So if you look at the bottom half of the PDP, the holes are bigger, and over there would be 40 amp breakers. And at the top would be rows of 30 amp breakers. And this is how we organize which motors go to which motor controllers, based on the robot's needs and functions. Right, so now this part is simple. You just connect all the motors you need to the motor controllers via the wires. And it's okay if you don't have motors connected to motor controllers. Like at the top left, there isn't a motor attached to the motor controller, but this robot would be working perfectly fine without it. Basically, you assign motors to motor controllers based on ID, and you can omit some IDs to make sure the robot works without motor controllers connected to motors. And for CAN, controller area network, you want it to be plugged throughout these three holes. So you start at the RoboRio, and you either want to end at the PCM or the PDP. And interesting fact, you don't actually need the PCM for the robot to work. So you can omit the PCM entirely and the CAN system can still work. But in this case for the robot, you want to make sure that all the CAN is connected and there are no gaps. And what that means is that the motor controllers each have two sides for CAN, so it can come from one input and then go to an output. So for the most efficient wiring, in this case, I would do this. I would start at the RoboRio. I would make my way through the left column of motor controllers, go to the PDP, take the other two holes from the PDP, and go all the way to the PCM, and you would have a complete CAN chain. No gaps, holes, or breaks. So this is basically how you wire a basic bellypan. Thank you for listening.